Hi folks, we're going to take a look at number 2 from the extra questions on the Unit 1 assignment. So here they're asking us to determine an expression for this function f. They tell us that f is a quartic function, and then they give us some information. Okay, so the idea is to decipher this information. So they're telling us that f at x is greater than 0 on the interval from -2 to 1, and then they tell us where it's less than 0. So what I'm going to do is just to keep things easy to figure out here, I'm just going to use a number line here. So between -2 and 1, okay, they're telling us that the function is positive. All right, and then they're saying that when x is less than -2, it's negative, and when it's greater than 1, it's also negative. And then they're telling us there's a double root at x equals 3. All right. So they're giving us information without giving it to us directly. They're not telling us that there's a 0 at -2. However, we can assume that there must be a 0 at -2 because we know that the only place for a polynomial to change sign is at an x-intercept. Same thing here. The only way for a function polynomial to change sign is at an x-intercept. So as it's going from positive to negative, means there must be an x-intercept at 1. Okay, so that means that our function, okay, must have a factor of x plus 2, must have a factor of x minus 1, and then here they tell us explicitly that there's a double root at x equals 3. So that means we also have factors of x minus 3 and a second one of x minus 3. So in other words, x minus 3 squared. All right. Now there is a little bit of a, looks actually a little bit of an error here because it says that it's negative for all numbers greater than 1, but clearly at 3 it must be equal to 0. So actually a little tiny mistake there in the question. And of course this is a quartic function because this gives me an x squared times x quartic, but we don't know which particular quartic function with these characteristics it is. All right, because there's a whole family of functions which have these characteristics. But of course, they give us this extra piece of information that's going to help us to find that multiplier. Okay, so now we just do what we always do. We replace that point, y equals 96, k is equal to -1. And now the only thing left is k. So let's solve for that. So 96, and here we've got -1 plus 2, that's just 1, -1 minus 1, -2, and here -1 minus 3 is -4, but it's being squared, so 16. So we have 96 equals -32k, and that actually looks like it's going to divide nicely. So that's just going to be -3 when I divide that out. All right, so my expression for f at x here is just going to be -3 times x plus 2 times x minus 1 times x minus 3 squared. All right, so to recap here, it was similar to many problems we've solved in the past, just the information was given to us a little differently by telling us when the function changed from negative to positive and positive to negative. It was essentially telling us that there were x-intercepts at those points because those are the only places where polynomial functions change sign. And then from there, we were able to write a family of polynomials and then input the given extra point to solve for the particular multiplier. Okay, that's it for this one.